Right. In this practice exercise, we're going to write a program to find the largest number stored in an array. We frequently search for data, smallest, largest, all kinds of different data, location. This time we want to find the largest number. All right, so I'm going to start off with an array of length 5. Let's just go ahead and initialize it with a list of known values. And so we know exactly what's there. Right. No particular order, right, of numbers. Some positive, one negative, right? If we look at this list that I just typed, we can very readily see in the small list that the number 45 is the largest number in the array, right? In order to get the computer to see that, we have to have the computer program walk through this array, element by element, to determine what the largest number is. What we can do is we can start at the beginning, and we can have the program look at the first number. So if you think about it, right? If we hadn't seen these other numbers, right, so let me just cut them out. If we hadn't seen these other numbers, if we only looked at the first number in the list, the first number is the largest number in the list, isn't it? So if we save that as our largest number in the list, so let me replace these. Right, and let's put a note that says the first number, or, all right, set the largest value to the first number, or the first element, right, the first element in the array. Let me make that array element for brevity. We need a variable then. Right, the largest number must be of type int because we have integer data types in the array. So I'll just call this largest. We'll say that the largest is equal to array at index 0. Right? We'll start there. And then what we can do is we can compare. So now let's think about it. If we had two things in the list, let me cut these out, Control X. Now if we had two things in the list and we've looked at this first one, we said, oh, 5 is the largest number. Well, we need to look at the next one in the list and say, is what we stored in the largest number greater than this number? Or smaller? Sorry, if it's smaller, in other words, if this number is greater than this one, then we have a new largest number, but it's not. Right? But we need to make that comparison. I'm going to say for int I equals, I'm going to start with 1. We've already looked at element 0, I less than length. Right. And with I, right, we're simply going to say if array at index I is bigger or larger, right, greater than what we've stored in largest, then we have a new largest number. So we say assign the largest that new value, array at index I. And so similarly, after we compare 5 to negative 3, we still have 5 as the largest number. So what we want to do then is 5 is in largest, we want to compare it to 45. We say, well, if 45 is greater than 5, it is, we want to store 45 in here. Right? And now we'll have a new largest, 45, that will compare to 19, and 45 will be compared to 2. When we get done, largest should have the value of 45 in there. So let's just go ahead and run the cursor. All right, so we can see now our array has 5, negative 3, 45, 19, and 2. All right, we have stored in largest the number 5 because we stored the array at index location 0, so subscript 0 in largest. Now we'll go in here and we'll start this loop. So next line, I was set equal to 1. 1 was less than length. That test was true. So now we'll compare array at location index 1, which is -3. Is -3 greater than largest? 5, no, that will be false. So we're just going to come back up. We're going to increment I to 2. 2 is less than length. And now we'll say array at index location 2, because I is 2. So is 45 greater than largest? That will be true. Right, so we'll set largest equal to that value. Right, we'll come back up, increment I. We're going to compare, now that I is 3, we're going to look at array at index location 3, which is 19. Compare that to 45. If 19 is greater than 45, well, it's not, so that will be false. Right, we come back up, add 1 to I becomes 4, 4 is less than length, so array at index 4, so this number 2 will be compared to 45, 2 won't be greater than 45, that will be false, we'll come back up, I will increment to 5, then this test fails, 5 is not less than 5, I is not less than length, so we pop down here, we can see that we have in largest the number 45. So now that we've been able to do this for a small set, we can test it on a larger set. Right? Rather than initialize this, let's go ahead and fill that array with random numbers. Right? We can still keep the same length if we'd like to. We're going to fill array with random numbers. Call the rand function, right, which I have the standard library already included here, so we can do that. Now, I'm just going to go ahead and declare I here, largest here, right, I won't redeclare it there, right, I like to try and declare all my variables at the top when I can. I don't want to redeclare I there. If I do, it's just local to that. All right, so here I need to start with I at index 0 because I need to fill the entire array. Here I start with I at index 1 because we've simply then already assigned the largest. So let's just go ahead, say run the cursor. All right, so now we can see that the array has been filled. So it's still the same size 5. So for us to easily look at the list, let's look here. The largest number in this list appears to be array at index 3, which is 26,500. We'll start by assigning largest to be array at index 0. Right? We have to have the computer, even though you and I can see this list, we have to have the computer look at the elements in the array one by one and perform comparisons. So next line, right now it thinks the largest number is 41. It pops in here, it starts with index 1. So array at index 1, right, is 18,467. That's going to be bigger than what we have stored in largest, bigger than 41. So we'll have a new largest value after this. Right? Come back up, increment I, test is true. Right, array at index location 2 is 6334. We're going to compare that to largest. That will be false. So we'll maintain that as the largest value. We'll increment I. Right, I is now 3, so we look at array location index 3. Well, that's the 26,500, which will be bigger than largest. So we'll replace that inside largest. Right, we have to finish searching the array, even though you and I can see that we have the largest value. Right, the computer doesn't know that, so it has to finish searching the array. Right. When we're all done, at the end, we see that we have the largest value is 26,500. So we've tested that with a known data set, right? Felt pretty confident. We saw that it was working. Now we tested it with random numbers. We're pretty confident that is correct as well, right? And if we want to, we can just simply change the length of this array, right? We could now generate 50 numbers. Right? When we get all done, we'll still have the largest out of all 50 numbers in there, right? Yeah. So this actually is showing us all 50 numbers. It says the largest is 32,391. Well, we'd have to look through the list. This will take a little bit longer. So we scroll through the list. 32,391. That is the biggest number I've seen so far. That is the largest number. So once we get that working on a smaller scale, it's not difficult then to just scale up the size of our array. Right? In this case, we're generating the same set of random numbers over and over again. If we were to stop the debugger and if we were to run again without seeing the random number generator, we would get the same results again because we get the same set of random numbers. Now let's go ahead before we see the random number generator. Let's amend this program and let's say we want to fill the array with random numbers in the range. Oh, let's see. 0 to 255. How's that? And then inclusive of the endpoint. So 0, 255. Right. So if I want to think of 255 as my high and low, let's even go ahead and create some variables. So I'm going to say high equals 255. Low equals 0. So we can go back to that formula that we saw in the lecture notes where we said we want to mod this by high minus low. Right? We have to add 1 back to it because we're not accounting for the 1 number at the endpoint. Right? So we want that operation to happen. Then after it mods it, we want to add back low. Even though low is 0 here, we're adding back 0. I just want to follow the formula. Right. So let's go ahead and let's make the array a little bit smaller for our testing. Let's do around the cursor. All right, so we can see, okay, we got numbers in the range of 0 to 255. The largest one happened to be 225 in this case. If we run this again, we're going to get the same set of random numbers. Let's see, let's make this a little bit bigger. Still let us scroll through the list easily. And let's go ahead and seed the random number generator. Okay. So we call srand. We're going to pass it, if we pass it time, right, that should be fairly unique, but if we pass it time, we need to include the time header file or the time library. And now run the cursor. All right, so we get 15 values. Looks like they're all in between 0 and 255. The largest happened to be 252, happened to be the first one on the list here. Right. And same thing, if we were to run this again, we should get a different set of numbers. Right. We do get a different set of numbers, different largest number as well in that set. Right. So that's how we can use that with the random number generator. We can specify a high and low range and get numbers within that range. We can easily make some changes to the length here if we wanted to generate more and check those. I think you get then the general idea of how to search for the largest number. We can see that no matter what size the array is, we follow the same procedure to do that.